All right, so this is day 13. We'll let you know what the homework's going to be at the end of this video. So you had 4 quadratic formula ones to finish up for homework. So 29, your A was 10, your B was negative 19, your C was negative 5. Fill those into the quadratic formula. Remember to put that B in parentheses and then squared. We put just the part under the radical, the numbers in, but not the radical. We get 561. Do menu number factor for 561. It does not give you any factors that are twice, so it doesn't break down at all. So just put them each individually over 20. In 30, we had to subtract the 72 over first. And now we could pick out our A of 1, our B of 19, and then our C of negative 72. Fill those into the quadratic formula. When you do the part under the radical, you get 649. Menu number factor of 649, and you don't get any factors that happen more than once. So just put them each individually over 2. Going to the next page, 31, we had to subtract the 2 over first. Then we could pick out our A of 1, our B of 13, and our C of negative 6. Fill those into the quadratic formula, put the numbers under the radical in, and you get 193. Menu number factor for 193 does not give us any factors that occur more than once, so just put them each individually over the 2. And in 32, we already had everything equal to 0, so our A was 1, B was 8, C was 10. Fill them into the quadratic formula. You get 24 under the radical. Menu number factor of 24 gives us 2, 2, 2, and 3, so we got a pair of 2's. One of those 2's comes out front. Divide each part individually by 2, and we get negative 4 plus and minus square root of 6. So today we are going to look at solving by completing the square. We did some completing the square earlier this year for straight circle equations, but now we'll use it to actually solve. Completing the square is helpful when things are messy, but usually if you have the option of what to do, if it's going to be messy, we tend to do quadratic formula. So usually don't do completing the square for solving unless the question specifically asks for it. And in Algebra 2, sometimes it will. That's why we're looking at this. So first thing we want to do is always get an A value of 1. So that's a leading coefficient of 1. Get any constant by itself on the other side. So that's the thing that doesn't have any variables. We're going to take half of our B value and square it. And that's what we are going to add to both sides. And then we're going to solve for the variable. So we've got a leading coefficient of 1. So that's a check. We've got to get the constant to the other side. So we're going to add the 8 over. So this will give us x squared minus 2x. And then leave yourself a little bit of space. And that equals 8. Well, now we want to do b over 2 and square it. Well, our b is negative 2 over 2, and we're going to square it. Negative 2 over 2 is going to give us negative 1. So we're going to do negative 1 squared. When you do these in the calculator, make sure it's in parentheses and squared. Okay, I'll say that over and over again. Make sure it's in parentheses and squared. Otherwise, it will give you back a negative, and it shouldn't. A negative times a negative is a positive. Negative 1 times negative 1 is 1, so we're going to add 1 to both sides. Writing this second step here makes the left hand easier. This is always going to be something times itself. We are completing the square. We want it to be a perfect square. So because we squared negative 1, this is going to be x minus 1 here. Now you could have figured it out that negative 1 and negative 1 are what multiply to 1 and add to negative 2, but when they become the more complicated ones, that shortcut is helpful. And this equals 9. Well, now we've got to solve. What we're going to do is we're going to take the square root of both sides to undo our squared. Now this is something we haven't had to worry about much in geometry, but when you choose to put a square root in a problem, it is up to you to put a plus and minus on the side that didn't have the squared. So in front of this radical, we will need a plus and minus. On the left, this is now just x minus 1. On the right, we'll have plus and minus, and 9's a perfect square. Square root of 9 is just 3, because 3 times 3 is 9. So we have x minus 1 equals plus and minus 3. So now we just write two equations. X minus 1 equals 3. X minus 1 equals negative 3. And we'll add the 1 over in each case. The first one giving us x equals 4. We'll add the 1 over on the other side. This gives us x equals negative 2. So those are our two answers, x equals 4 and x equals negative 2. Now, just like all of our solving of quadratic equations, what this is really telling us is where the graph is crossing the x-axis, because that's where it would have a y value of 0. We're going to move down to question 3, right underneath it. The first thing we always needed was a 1 in front of our squared term, the a value. We've got that, so we're good. Then we need to get the constant by itself on one side. Well, this one's kind of nice. They already have the constant by itself on one side. I'm still going to rewrite it, though, so that I have a little bit of space. So p squared minus p, leave a little space, and then equals 2. We're now going to do the actual act of completing the square. We've got to do our b value, which is negative 1, over 2, and then square it. So it'll always be your b value over 2 and then squared. Well, this is just negative 1/2. It doesn't simplify at all. So when we square it, you can put that right in the calculator, or you're just squaring the top and bottom, and we get 1/4 back. Well, this is where knowing the shortcut on the left is helpful. We're going to have something squared. We're going to have a p, and well, it's whatever got squared. Negative 1/2 got squared, so we're just going to have a negative 1/2 here. In our calculators, we would just do 2 plus 1/4, and that gives us 9/4. We'll now take the square root of both sides, remembering to put the plus and minus in front of the side that did not have the squared. On the left, the square and the square root wipe out, so we have p minus 1/2. On the right, we're going to have plus and minus, and we just do the square root of both parts. Square root of 9 is just 3. Square root of 4 is just 2. And now we'll just write two separate equations. P minus 1/2 is equal to positive 3/2, and p minus 1/2 is equal to negative 3/2. Get p by itself by adding the 1/2 over. And you could type this in your calculator if you weren't sure of it, but 3/2 and 1/2 gives us 4/2. 4/2 is just the same as, oops, not 4, but 2. So that's one answer. If we add the 1/2 here, again, you could type it in your calculator if you wanted, but negative 3/2 plus 1/2 gives us negative 2/2. Negative 2/2 is just the same as negative 1. We're going to move down to the one right below it, number 5. We've got a 1 in front of our squared term, our a term, so that's good. And then we need the constant by itself. Well, this one, the constant's not by itself. So let's maybe subtract the 7y over first to get it with the y squared. Now, the reason we would do that as opposed to bringing the y squared to the left is we want a positive 1 in front of the y squared. So right now, this is y squared minus 7y plus 12. And then we'll get that constant over to the other side by subtracting the 12 over. So we've got minus 12 equals y squared minus 7y, and we've got our little bit of space after the minus 7y. So we're going to actually do the act of completing the square. We always do our b value over 2 squared. So we're going to have negative 7 over 2 all squared. Negative 7 over 2 doesn't reduce at all. So when we square that, 7 times 7 is 49, 2 times 2 is 4. So we'll have 49/4 on both of these. Over on the left, if we add those together, we're going to get 1/4. And on the right, we'll have something squared. Well, the thing that we squared was negative 7/2, so we'll have y minus 7/2 being squared. We're going to take the square root of both sides. The side that didn't have the squared should get the plus and minus out front. So we'll have plus and minus. Square root of 1 is just 1, because 1 times 1 is 1. Square root of 4 is 2, because 2 times 2 gives us 4. And on the right, we'll just have y minus 7/2. So just like we finished the other ones, we can write two equations. Positive 1/2 equals y minus 7/2. And negative 1/2 equals y minus 7/2. We'll add the 7/2 over in each case. One half plus 7/2 gives us 8/2, which is the same as saying 4. If you're unsure of that, again, you could just punch it in your calculator. Negative 1/2 plus 7/2, well, 7 minus 1 is 6, so that's 6/2, which is the same as 3. So y equals 3, and y equals 4. We're going to jump down to, on the next page, number 7. We're going to solve this by completing the square. First check is, do we have a 1 in front of our squared term, which we do. Then we got to get the constant on one side by itself. So we'll add the 30 over. So this will be n squared plus n, leave a little space, and then equals positive 30 now. We're going to do our actual act of completing the square, where we do our b value, which is 1, always divided by 2, and then squared. Well, 1/2 doesn't reduce it all, so we can just go ahead and square that. Square the 1, square the 2, we get 1/4 that we'll add to both sides. On the left, this will be something squared, and the thing that we squared was 1/2. So n plus 1/2 all squared. And 30 plus 1/4, if you put it in your calculator, is just 121 over 4. To undo the squared, we'll take the square root of both sides, remembering to put the plus and minus in front of the radical on the side that did not have the squared. This will become n plus 1/2 equals, and both those are perfect squares. 11 times 11 is 121, 2 times 2 is 4, so we just get 11/2. We'll finish it off like all the others. We'll write two equations. N plus 1/2 is equal to 11/2. Oops, I forgot my plus and minus here, sorry. Is equal to the positive 11/2. And n plus 1/2 is equal to negative 11/2. And we'll finish off by subtracting the 1/2 over in each case. Eleven halves minus 1/2 gives us 10/2. 10/2 is the same as saying 5. Negative 11 minus 1 gives us negative 12/2. Negative 12/2 is the same as saying negative 6. So those first four examples we did, 1, 3, 5, and 7, are ones that end up reasonably nice in the end. Our answers are nice, even though we had fractions along the way, everything ended up pretty nice. We're going to go to 9 next, and we'll see that that's not always the case. Just like in quadratic formula, our answers didn't always end up nice. Same thing with when solving by completing the square, because we're really doing this, trying to get to the same thing, the place where we cross the x-axis, and that's not always going to be something nice. Well, notice in 9 we have 1 in front of the t squared, so that's good. We've already got the constant by itself, that's good. I'm just going to rewrite it so we have the space after our 3t. So we've got to do our b value over 2 and square it. So we'll have 3 over 2 squared. 3 over 2 doesn't reduce, so we'll just go ahead and square it. 3 squared is 9, and 2 squared is 4, so we get 9/4 on both sides. Hopefully this factoring on the left becomes pretty easy now. The thing we squared was 3/2, so we'll have t plus 3/2 all squared. The right side you can just punch in your calculator, and we get 57/4. We'll take the square root of both sides, remembering to put plus and minus in front of the radical where we did not have the squared. This is going to be t plus 3/2 equals plus and minus, and this is where it's a little different. Square root of 4, that's nice, is 2 times 2. But in the numerator, square root of 57 is not a perfect square, and if you did menu number factor for 57, it would just give you 3 times 19, so there's no pairs to circle. So that means we just leave this as square root of 57. This looks messier, but it's actually a little less work. Just like in quadratic formula, when the radical did not simplify, our final answer, we just left it as something plus and minus something else. We're going to do the same thing here. So to finish this up, we're just going to subtract the 3/2 from both sides. And so that it looks like our answers from quadratic formula, we're going to put that negative 3/2 first. So you got negative 3/2 plus and minus square root of 57 over 2. And if you compare that to some of our answers from the homework, notice it's very similar looking. You've got some fraction plus minus a square root over some number. Okay, because really we're doing the same thing. It's just a different technique to do that. So we're going to go ahead to 11 now, the one below it. We've got a 1 in front of our n squared. That's good. Constant is not by itself. The constant, again, is the thing that does not have any variables, so let's subtract that over. We'll have n squared plus 8n, leave a little space, equals negative 10. Our act of completing the square, you take half of your b value and put our b value over 2 and then square it. So we'll have 8 over 2 all squared. This does neaten up. This is really 4 squared. 4 squared gives us 16. So we'll add 16 to each side. On the left here, this will really be n plus 4 all squared, because 4 is what we squared when completing the square, and this equals 6 now. We'll take the square root of both sides, remembering to put a plus and minus in front of the one that does not have the squared. The square and the square root wipe out to give us n plus 4. And square root of 6 is not a perfect square. Menu number factor, you'll just get 2 times 3. So there's no repeat factors, so we just leave it as plus and minus square root of 6. And to finish off, we'll subtract the 4 over. We'd like to put that out front. We'll have negative 4 plus or minus square root of 6. We'll go to 13 and do one last one in this video, and then we'll give you the rest of the time to do the homework ones. So we've got a 1 in front of our x squared. That's good. Our constant is not by itself, though, so we got to add the 20 over. So we'll have x squared plus 12x, leave a little space, and that equals 20. Our act of completing the square, we'll do our b value of 12 over 2, and then all squared. Well, 12 over 2 is really 6, so we'll be doing 6 squared, which is 36. That will add to both sides. On the left, it's just going to have inside the parenthesis whatever we squared, so we'll have x plus 6 squared. Hopefully that part's becoming really easy by this point. Add the 20 and 36 together, we get 56. We're going to take the square root of both sides and put our plus and minus out front. This will give us x plus 6 equals plus and minus. Square root of 56 is not nice. But if you do menu number factor of 56, you're going to get 2 times 2 times 2 times 7. Well, we've got one pair of 2, so one of them is going to go out front. So this will be x plus 6 equals plus and minus 2 square root of 14. So you do need to check if the radical doesn't come out nice. You need to do the menu number factor to see if it does simplify. And to finish off, we'll subtract the 6 on both sides. We like that -6 to come first, and then the plus or minus 2 squared of 14. Because then it looks like an answer that we would get from quadratic formula. Really, all that's telling us is where our parabola is crossing the x-axis. All right, so your homework is page 20 to 21. You're doing numbers 2 through 14 even. So you should have some time now to be working on those in class, and anything you don't finish, make sure you turn it in before next class right on Schoology. Have a great rest of your day.